Okay, how can I look at the periodic table and say that the P subshell has 3 orbitals in it? Okay, or how can I look at the periodic table and say that the D subshell has 5 orbitals in it? Okay, so let's look at both of those questions. Okay, so what do we know about each orbital in particular? How many electrons can an orbital hold? 2, right? So when we're looking at the periodic table, what we're seeing is atoms that are increasing in the number of electrons by 1 relative to the atom previous to themselves. Does that make sense? Right? So in other words, if I look at aluminum, it has 13 electrons, and silicon has 14 electrons. Is everybody with me right now? Okay. So if I look here, right, and I say, well, how many orbitals do I need to be able to fully house 1, 2, 3, 4, 5, 6 electrons if 2 can occupy 1 orbital? How many orbitals would I need? 3, right? 3. Because 2 times 3 equals 6, right? So if I'm looking at the D block, right, this was the next question we had, right? How do I know that the D subset has 5 orbitals within it? Well, all I have to do is look, and I know that each orbital holds 2 electrons, so all I have to say is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 divided by 2 is how many? 5, right? So that makes sense, right? So when I look at the S's, how many orbitals do I have in the S? Subshell. Orbitals. 1, right? Because it can hold how many electrons? So let's just prove that to ourselves. 1, 2, right? So 1, 2, that's 1 orbital.